Hi, I'm Otto Schnurr. I'm a software engineer at TechSmith. This collection of videos has been made possible by the innovation time that TechSmith offers its software development staff. But the opinions you're going to hear are my own. They don't necessarily represent the opinions or strategies of TechSmith. Okay, with that out of the way, the first thing I'd like to say is that I've been interested in machine learning for quite a long time. At the beginning of my career, I had the opportunity to work with the technology, basically being the equivalent of a neural network engineer for about 3 years. And every time I've had a chance to work with the technology, I walk away thinking that it's really interesting and fascinating. And like a lot of new technologies, machine learning can come across as fairly mysterious, kind of wrapped in a shroud of mystery. And the hope of these videos is to try and help remove some of that mystery. So some of the things we'll be talking about is, why is machine learning important? What is machine learning and how does it work? And what kind of opportunity does it represent? Some of the things we won't be talking about in this particular collection of videos is specific machine learning algorithms. That's going to have to be set aside for some other time. But before I dive into a talk about machine learning, there's another topic we should talk about first. So the truth of the matter is there's a lot of hype surrounding machine learning these days, and the hype goes in both directions. There's a lot of positive hype, and I'm actually guilty of that myself. I tend to fall on the side of the fence that sees machine learning as something that's exciting and has a lot of opportunity associated with it, but there's also a lot of hype that's highly negative. There are folks out there that are really worried about, in the long term, where machine learning might go. So I guess I humbly disagree with some big name folks like Elon Musk and Stephen Hawking, who are concerned, from what I understand, are concerned about how this technology might interact with something like a singularity, and we have unexpected results with unintended consequences that could put the entire human civilization at risk. So I follow a lot of folks on Twitter who do machine learning as their day job, and those folks do have concerns, but they're not these really gigantic concerns about the survival of humanity. They're more short-term in nature, ranging from things like autonomous weaponry and whether humans should be involved in the loop when dealing with targets in the battlefield, ranging from that to things like bias that might be present in data that trains machine learning models that make important decisions like criminal sentencing or sifting through resumes for job applicants, those kinds of things. And I think one thing that all of these folks, including myself, have in common is that none of us necessarily think it's going to be the Hollywood version of Skynet that has this machine intelligence that doesn't like us and wants to get rid of us. The truth of the matter is maybe it actually won't be that extreme. It won't be spectacularly good or spectacularly bad. Maybe it'll be something more mundane. And as kind of a penance for contributing to this machine learning hype myself, I've decided to stick some anti-hype right in the beginning of this video. This is something that showed up in my Twitter stream. I think it's from a subreddit. It's kind of, I think, helpful to think about what the gaps are between human intelligence and machine intelligence, and to see where those gaps are still quite big. To be completely transparent, it's not necessarily the case that some of these robots are even using machine learning, but it's still interesting to look at them and, kind of get a little bit grounded that what we take for granted in terms of just being able to walk and stand up is something extremely difficult. I think one of the things that's interesting about these videos in particular is that when they start to fall, you don't see this built-in instinct to move your arms and legs in a way to stop the fall. So another way to look at this is to look at the field of computer vision, which is an area that machine learning has been making a lot of progress in over the last couple of years. There was a meme a couple of years back that I think is kind of entertaining and interesting to think about when you think about the field of computer vision. So could it be possible that machine learning might have trouble telling the difference between a Chihuahua and a blueberry muffin? Maybe. Could it have trouble telling the difference between labradoodles and fried chicken? Maybe. Does machine learning get confused by satellite imagery? Well, we've got an example right here of that. So on the lower right here, the algorithm thinks that this is a picture of an umbrella. And if you look at the roof, you can kind of see where it's coming from, but it's all a matter of context, right? Because if we look at that and look a little bit to the left, we're thinking, well, that looks an awful lot like a parking lot. And that helps us understand what the image is, right? Probably my favorite one is over on the left, where a building is casting a shadow. And the algorithm thinks that shadow kind of looks like a pirate ship. But you can see from the percentage there, it's not very confident. It's like, well, it might be a pirate ship, I'm not sure. But when you look at the top row there, the algorithm is saying, trust me, this is a banjo. Absolutely a banjo. What else could it be but a banjo, right? And again, this is all a matter of context, of being able to tell the difference between the neck of a banjo and something that looks like a driveway. So this is something where we can kind of see where the machine learning algorithm is having trouble, and we can kind of understand why it's having trouble. But it's another case of where human beings have enough perceptive intelligence to be able to look at this driveway coming in to this building and not think that it's the neck of a banjo. And here's another interesting example to think about. Does the director of AI at Tesla lose sleep over an image like this one here? Well, it turns out that he does. How do we know this? Well, he's said so himself. So this is Andrej Karpathy. I hope I pronounced his name correctly. He's the director of AI at Tesla. And these folks are trying to get cars to drive themselves, autonomous vehicles. So I'm going to play a clip, and he's going to talk about a lot of stuff that we're going to end up covering later on. But for now, I just ask for you to bear with it. But one of the things I wanted to talk about ahead of time is that he's going to talk about this concept of labeling. And labeling data is when a team of human beings sit down with a big data set, it could be images or video or something else, and they manually annotate the data with additional information. It could be stuff like this is a dog, or this is a cat, or this is a street sign, or this is a car, or whatever problem you're trying to go after. And that additional information is placed with the data in a way that the computer can read it. So labeling data is a human process, but the idea is that the machine learning algorithms could eventually come up with an association between the data and the annotations on its own, or maybe even predict what the annotation is on stuff it hasn't seen before. That's one of the basic tenets of how machine learning works, and Andrej is going to talk about that right here.
But massaging the data set, cleaning it, assembling it, is just like a complete disaster because there's a lot of things we want to predict, and we need to collect data set for all of it. We need to make sure it's large, varied, clean, and that takes a lot of time. So some fun lessons learned the hard way. The first thing I learned is this piece of data labeling is extremely highly non-trivial. So you think this would be straightforward. It's super not straightforward, and that's why it requires so much infrastructure. So for example, we have an image we're trying to drive. So of course, what's really important is, well, we need to be able to identify the lane lines so that we can stay inside them. It seems kind of like an important thing. OK, so, well, there's a lane line there, lane line there. How hard could that be? You go out to the real world, it can be really, really hard. So you come up across images like this. This is in Europe. And then you're suddenly not sure. So you create your labeling instructions, and then you label some data, and then you come up with this, and you're like, oh, man, I don't know, like, should we be zigzagging? Should we be interpolating? It's not really clear how you should be labeling this. Do we deal with this in a network, or do we deal with this in post-processing? So philosophical conundrums. Then you come across here, and you're like, oh, man, I'm not sure. I guess we ignore that. I guess. And now you have to add this image to your labeling documentation because people will be confused. And suddenly your labeling documentation becomes like, a billion pages. You come across this. You're like, what the hell is that? Like, why? Do you go around? I don't know. So this is in our labeling documentation. If you're trying to annotate vehicles on the road, you might think it's straightforward. You put bounding boxes around cars, right? We should probably, do that. And then you come across things like this, pretty common. Is this 4 cars? Is this 1 car? Is it 2 cars because of a joint? I don't know. I'm not sure. But you have to come up with something, standardize it, and make it work.
So the thing I keep hearing from practitioners of machine learning is that when the rubber hits the road and you're pursuing a machine learning solution for your problem, somewhere between 80 to 90 to 95% of your time is spent just getting your data into a good place. So unless the data set is already handed to you in really great shape, you're going to spend a lot of time getting the data ready, and relatively speaking, not as much time deciding which algorithm to use and doing the actual training. And the other thing I'd like to point out is that, again, the difficulties he's talking about and the difficulties that he's worried about are things that human beings are able to navigate in a reasonable way. So if you're someone who's worried about software getting too smart for its own good, you could argue that one of the smartest technologies on the planet right now is the Google search index, right? It knows a lot of stuff. I mean, I don't know how to cook lasagna, but I can get a good recipe from Google if I type it in. And the question I'd like to pose here is that, is it really the case that the Google search index actually knows what lasagna tastes like? Or does it happen to know a lot about web pages that talk about lasagna and how those pages are connected to each other on the internet? One of those things involves, actually having taste buds and being able to understand how things taste. And the other one is just understanding structure of something that can be examined, as data. But for someone who might not know any better, they might look at this thing on the left and make some assumptions about what's happening that look like the thing on the right. That same mistake can happen with machine learning as well. Machine learning is not necessarily intelligence. It's about mathematically creating associations and things of that sort. There's a joke I ran across a few months ago, and it goes something like this. A machine learning algorithm walks into a bar. The bartender says, "What are you having?" And the machine learning algorithm replies, "Well, what is everybody else having?" I mean, it's not a great joke, but it kind of gets to the point of what we're talking about here. So that brings us to the end of this first video. The next video is going to be digging into a little more detail about why machine learning is important and what kinds of problems it lets us tackle that were hard to go after before. So if that sounds interesting, please subscribe. You can also find more information at my blog, deepdojo.com. Thanks again. I'll see you next time.